Okay, hey guys, it's another time again to talk about another project. And before we get started, let me just know how you're doing. How's your programming journey going? It's really amazing to have you back. Hope you are finding health and hope you are learning. Today we are looking at doubly linked list. Okay, if you understood the concept of singly linked list, this is more like growing with that concept. All right, this is more like growing with what you know about singly linked list. So by question, by way of you know what you are talking about, what exactly is doubly linked list? It's a special type of linked list in which each node contain a pointer, so previous as well as next node. That's the major difference between the singly linked list and the doubly linked list. um in single linked list, you only have a node pointing to the next pointer. You don't have a previous, a previous arrow pointing to the previous node. So but in doubly linked list, you have that. You have both the next and the previous arrow pointing to the next node as well as the previous node respectively. So because of that, we could say that in a doubly linked list, uh, it can be transversed in both directions. So you can move both to the right and to the left. You can move forward and backward in doubly linked list. And here I want you to take note of these three compartments in doubly linked list. You have previous, you have the data as well as the next arrow. So for the previous, it is the address of the previous node. Okay, that means when we are pointing the node backward. Then for the data item, it is used to store what you want to hold in that compartment. You could say a node is a compartment, and that could either be a number, it could either be a string, it could either be an image, whatever is used to hold the data in the node or the compartment. Whereas the next is the address of the next node. So that's the address of the next node. So basically that is that. And we want to look at application because so most of the project you just look at, okay, I'm working on the project. You appreciate it more when you understand the application of that project. So what are the application of doubly linked list? One, you use it to redo and undo functionalities in a software. Okay, you can use it transverse because it can transfer both front and back. You can use to redo and undo functionalities in a software. Then both forward and backward navigation in browser. More like you can see this arrow, right? Okay, you can see this one pointing forward. So it's a practical example of what we are talking about. You can use it to navigate both forward and backward, right? Then it's used in applications like music player, where you need to go to the next or previous song. You have a music player, you want to move to the next song, or you want to go back to the previous song. That is a perfect example of what a doubly linked list can actually do for you. So that is it for the theoretical part, right? Let's now dive in to talk about what we have in the code. All right, so this is it. Then for the project, start looking at it, doubly linked list, and okay, these are the objective and requirements. You have to go through all of that to understand what we are talking about. And talking about, okay, the quiz session, I'll have a different video for that. So yeah, we start creating the files. For the files, I'll leave the source code in the description of this video, so you can always check out and look through the file. So it's best for you to understand what is happening. That is why I'll try my best to say I explain what is happening in the code, so that you have an idea or understand what you are doing, why you are doing what you are doing. So for this, let's navigate to our repository. Okay, So I'll just pick this from here. All right. Then I'm going to, so if you come here, the next thing you want to do, you want to make a directory mkdir arrow. So you pick this from here, that's the Doubly Linked list, the directory you want to create using your command. Then you're going to paste this right here. So if you hit that, it's going to create that, but because I already have that, so it's going to throw an error. So since I already created that, like I said, I'm just going to go ahead to cd into that directory. I advise you watch this video to the end, because we are going to go with an explanation that will really guide you in the process, right? So I'll do cd, and that will help me take me to the directory. All right, we have that. We have navigated. Since we already created that, we have that. So the first thing we're going to do, we're going to start creating the individual files. So the first one, like we always do, we want to have a readme file because it's a requirement. Readme.md file. Okay, so this is it. This is just a simple readme file. You could go ahead to have yours. Go ahead to put whatever you want to put there. How the project work, what is Doubly Linked list application, like I itemized earlier. You can write them up in the readme.md. So this is the part to do that. So I just added a simple one to that. So after you do that, you escape the color WQ to save and quit. So after that, you want to have the main.h file. Okay, here it is actually called the list.h file. So it's called the list.h file. So you want to have that. So that's where you are going to add all the prototype for the project. All the prototype, going to put them in a file called the list.h file. So to create that file, you do this, and you're going to come here. So all of the prototype will be here, and these are the prototype, right? So since we are talking about Doubly Linked list, we are talking about Doubly Linked list, we are working with what is it called, with structures. So you have those structures definition inside the list.h file. They are well defined inside the list.h file. So because we are talking about Doubly Linked list, so the next file we want to create is the first one. We start creating each individual file. So for the first one, we have this. Write a function that prints all the element of a DList list int underscore t list. Okay, so this is what we are going to do. We're going to create this file. All right, so to do that, we are just going ahead to pick the file name. Okay, I believe you understood what we said in the list.h file. The list.h file. This is the list.h file. Okay, so here first we have the header file, then we have the comment section. because we are talking about doubly linked lists, you know that it goes hand in hand with structures. We are using data structures. So these are the prototype. Then this is the structure. Okay, so this is the structure. So if you don't know anything about structure, I would advise you look through the concept, because type def struct, that's what was used, and we initialize the variables here. This one is variable n, and this is a pointer to, you know, a pointer to the structure, to the DList int structure. Then this is a pointer to the next next node. Okay, so that is what we have there. So you put that in your list.h. You can save and quit, and after that you go ahead to create the first file. So for the first file, please, I want you to watch to the end, because I'll be explaining what is happening. So for this, we are just going to pick this up. You do vi, you paste that in 0 print underscore DList int dot c. All right, so this is what we have here for this first file. What are we looking at? We are trying to write a function that prints all the element of this list, DList int underscore TList. So we are trying to print that, and the prototype which we are given is this. So then return the number of nodes. So we are trying to print that. So this is it, and we're including the list.h because that includes our prototype. We are referencing it in this file. Then this is the comment section that is Betty compliant and follow the Betty documentation style. So here, what we have here is the function name, which is print underscore DList int, which is according to the prototype we are given here. We are given a prototype to work with. So the function is the function named print underscore DList int. It takes a single argument and is a pointer to the constant structure used for the doubly linked list. So that's the argument that's passed into this. Is a pointer, okay, which a constant pointer which point to the structure used for the list. So we declared a variable called count, and it's going to return an integer. It's an integer variable, and we initialize count to be 0. And we went further to use this conditional statement, this conditional if statement. So it's going to check if our h is equal to none. So it's going to check if is equal to null. Why is it doing that? Why that? Because it means that the list, if it is null, if our pointer here is null, then it means that the list is empty. So if it is empty, then you are going to return count, and count is what? The value of count is 0. So if it is null, then return count, and the program will end there. So value of count is 0. So if h, which is our pointer here, is null, then return count. So we go ahead to use a while loop here. So what this while loop is doing is going to transverse the nodes. Okay, it's going to transverse the node. So it transverse backward by the previous. So we talked earlier, we talked about the previous and next arrow. The previous arrow point backward. Okay, so it's going to transverse backward to the previous node. and it's going to ascertain if the previous node is not null. If it is null, that means it's going to end the program. So it's going to transfer backward to check if the previous node is not null. So it moves through until the previous node becomes null. So what is this? The loop finds the head of the list by moving h to the first node. So we talked about, okay, to demonstrate that, I wanted to show you this earlier. In a linked list, you have, these are the node A, B, C, D, and these are the arrows pointing to the node. The first node is the head, while the last one is the node. So the previous, this arrow, they transverse both forward and backward direction. Okay, that is different between doubly linked list and single linked list. So this is the head, and this the first node, second node, and third node, and the fourth node. So it's what we are saying earlier. It's going to move through to the previous one till it get to null, or till you experience this null. Okay, so that is what we are talking about. So when it transfers that, then okay. So when it does that, while h is not null, as long as the pointer h is not null, then we are going to print the value of count. Okay, so this is a format specifier, which means we are printing a decimal value in a new line. So it's going to print that, and it's going to increment it by 1. Going to increment that by 1. So then we are going to point the pointer arrow. We are going to point it to the next node. After that, so we'll point it to the next node. So after that, we are going to return whatever is stored in this variable count. We are going to return it. We're going to display that to the console. So that is the program. All right. So please, if you are confused, you can drop your question in the comment section. We're going to discuss that together. So after that, you do your save and quit. So after that, then we go ahead to create the next file. So I'll copy the file name, one list int underscore len.c. I'll do vi. All right, so this is the file. What we are trying to achieve here is that we want to write a function that returns the number of elements in a linked DList int underscore TList. Okay, that returns the number of elements. So we want to calculate the number of elements and return whatever value that we get. So this is the comment, which is Betty compliant, and this is the function. The function name is this DList int underscore t, and it has one argument, which is this. It takes a pointer as an argument, and a pointer to the DList int underscore t structure, and it's going to return this. It's going to return this size underscore t data type. It's going to return this size underscore t data type. So we declare our variable. Yeah, we're going to declare an integer variable, which is called count, and initialize its value to 0. Then we use this conditional if statement. Okay, so if h is exactly none, return count. So as long as the pointer h is none, then return count. Okay, so then we go ahead to, like we did earlier, we're going to use a while loop and point the pointer to the previous node as long as it is not null. If as long as the arrow pointing backward is not null, then continue pointing that arrow to the previous. It's more like you are transversing through the nodes, and you are transversing through the node. Maybe you are here in this node, it points to the previous one, which is C, and you got here, it's what you have, next previous. So as long as there's no null here, it points to the previous one, which is B. Then you have next previous. You want to go back, points to the previous one, which is A, then before it encounter null. So as soon as it encounter the null, then it's going to stop. The program is going to stop. So we are what we are trying to do is we are transversing through, the linked list. So then here we have YH is not exactly none. So it counts the number of nodes in the doubly linked list, the number of nodes, and it increments the count variable by 1. This count plus plus will increment the count variable by 1 each time it encountered the node encountered and moved to the next node. So it increment that. After increment that, then it's going to move to the next node. Then at the end of the day, after I count, then the function will finally return the count variable, which now holds the total of number. You know what we are trying to do? It now holds the total number of nodes in the doubly linked list. So that will help you count, return the number of elements, or count the number of elements in the linked list. So that is that for that. So once you're done, you could do your shift column WQ to save and quit. So after that, we're going to talk about this, the add node. Write a function that adds a new node at the beginning of a linked list. Okay, that add a new node. So we've talked about to count, we've talked about to calculate the length of the node, and we have talked about to print the number of elements in the node. So this time we are looking at, we want to add a new node at the beginning of the list. So to do that, first let's copy the file name. So I'm going to do vi and we paste that. Let me add that space. Supposed to be a space there. So after that, all right. So again, we have this. So what we are trying to do here, we are trying to add another node, a new node to the beginning of a linked list. You could have another function or program that add a new node to the end, but this first one is going to add a new node to the beginning of the list. So the comment section, though we have the function, and the function name is this. This is the function name. So we have some arguments. We have 2 arguments in this function, the head and n. So the head is a pointer to a pointer, a double pointer. It's a pointer to a pointer to the D-linked it underscore T, which is the double linked list, and it represents the end of the list. So this double pointer, a pointer to a pointer, it represents the head of the list. So we have a constant integer variable. We had a constant integer argument here, an integer value that will be stored in the new node. We're going to store it here in n. So at the end, the pointer is going to the function returns a pointer to a D-links it underscore T. The function will return a pointer to a D-linked list underscore T. So that will be, which represent the address of the element that will be added to the list. So we declare some variables here. So the first one, we declared a pointer to a DList int underscore T structure named new. And the pointer will be used to store a temporary pointer. It will be used as a temporary pointer to transverse the list. Then we declare another pointer, a second pointer to the D-linked list structure named this, and it will be used as a temporary pointer to transverse the list. So these are the variable that are declared here. So as soon as we start the program, then the function, the dynamically allocate memory location for the new structure and assigned a pointer and assign to point the pointer to new. Okay, so that is what we have there. And if new is null, then return null. So if the new node is empty, if the new node we are trying to add is empty, so the function node will be immediately displayed. Okay, so it means that no memory will be allocated for the creation of a new node. So here then we have this line which assign the integer value n to the n member of the newly created node new. We assign the integer value n to the newly created node. So what that does is that it's going to initialize the value of n, and so the new arrow pointing to previous and equal to none is going to set the previous pointer of the null node to null. So this indicates that the node is being added at the beginning of the doubly linked list. So it's going to initialize the value of previous to null. So that means we want to add it to the beginning and not any other position. And then we initialize the temporary pointer with the h with the address stored in the head pointer. This allows h to be used to transverse the list without affecting the original head pointer. So then we go ahead to use a conditional statement here. If h is not null, so if h the pointer is not null, then we go into a loop and we transverse through the loop. Wherever point the arrow is going to transverse through the loop, and as long as we have not gotten to null, then continue moving the arrow backward. Okay, continue moving the previous arrow backward to the previous node. But as soon as we encounter null, then stop that transverse movement. All right, so then what we go ahead after finding the first node, this line here is going to set the next pointer of the new node new to point to the first node h. Okay, new is going to point to the first node h. So it connects the new node to the rest of the list. So new is going to point to the first node H, and we connect the new node to the rest of the list. So, and then we use an if statement to determine if the list is not empty. Then set previous pointer of the first node H to point back to the new node. Okay, to point back to the new node, completing the connection. We want to if list is not empty, if not null, that is what we are talking about, then set previous pointer of the first node H to point to the new node, this new node, to point to the new node. And we have this pointer head equals new, that updates the head pointer to point to the newly added node, making it the new head of the list. So again, what we are saying is that as the node is being created, you want to displace the one that was the previous head and add a new node at the beginning. So this is what is being done here. An updation is required. Okay, this head equals new. Update the head pointer to point to the newly added node, now making it the new head of the list. So I believe you understand that. Then after all said and done, return the new node, to show that the program have run successfully. So the new created node will be returned to show. In all, we are trying to add a new node to the beginning of a linked list. So that is what we are trying to do. So after you do that, you can keep column WQ to save a quit or write a quit. So I've added a new node. So write a function that had a new node at the end of a linked list. Okay, remember we just added to the beginning. Then we are writing a function that add a new node to the end of a linked list. So that is what we'll be doing in this other part. So you're going to pick up the file name. So I'm going to put it right here. All right. So basically, I'll just, since you already know how to add to the previous to add to the beginning of the node, we want to add a new node to the end of the node. So basically, is similar to what we did before. So the only thing is that rather than do previous, you're going to do next. Okay, so rather than do previous, we are going to do next, because we want to transverse through the, so we are transversing the node to the end of that node. So after doing that, so the code here is going to add, the code extend a linked list by adding a new node containing the specified integer value to the end, to the end of the node. And we're also trying to maintain proper linkage. There should be a proper linkage between, there shouldn't be a disconnect. The node should be added properly for that to work. So that is what this code is going to do. It's going to add a new node to the end of a linked list and extending the length of that list. So at the end, you can do your column WQ to save and quit. To write a function that frees a D-linked list. Okay, so that's the next thing we are looking at. We want to write a function that will free a list. So we go ahead and pick up the file name. All right, so what we are looking at here is that we want to free a linked list. And you know, to free a linked list, you are trying to free the memory location of that a particular chunk of memory of that list. So we have, this is the function, and the function name is this free underscore the list int, and it's going to return void. It's not going to return any parameter. And we have an argument to this function. So the function DList takes a pointer to the DList int underscore t. So it takes a pointer structure as its parameter, and that pointer is called head, and it represents the head of the list. The pointer represents the head of the list. Then we declared our variable, and this variable is of this type, the list int underscore t, and it is a pointer. It is a pointer to this structure. Okay, structure as, and is the TMP. TMP is a pointer to this DList int underscore t type. So we start with a conditional statement. If head not null, it check if the head pointer is not null, which ensure that the list is not empty. So if not null, it means that if the head, which is the first node, is not null, that means it's not empty. Then we use a while loop, which iterates, which loops through the head, through the, if the head while head arrow to the previous is not null. Okay, as long, this is what we are talking about, as long as the arrow that moved to the previous node is not null, so it's going to iterate through, no matter the point we are in the node, is going to move. If it's at the end of the node, it will move backward, right? If it is here, it's going to move here. So moving through every point of the list, moving point through every point, as long as head is not null. So until it reaches the very beginning of the list, it will not stop until it reaches the beginning. So the beginning is the point at which head is null. So the step is actually important to ensure that the head points to the first node in the list before we start to free. We want to free the list, so it ensures that the head point to the beginning of the list before we start to free the node. Okay, so then why head is not null, so this assigns the current head pointer, to the TMP variable. The current head pointer is the point to the node to be freed. So the head pointer points to the node to be freed. So what we are doing here, we want to assign the current head pointer, sorry about that, to the TMP variable. Okay, so then we go ahead to do head equals head arrow pointing to the next variable, which updates the head pointer to point to the next node in the list. So it will update the head pointer to point to the next node. So at the end, we are going to free the list. So the code deallocate the memory used by the Doubly Linked list, starting from one head and pointing to the end. Okay, for the next one, we are going to write a function that returns the nth node of a DList int underscore t linked list. So this is a prototype which is already included in the header file list .h. So they said where index is the index of the node starting from 0. If the index does not exist, return null. So the first thing we are going to do, we are going to pick the file name from here. 5get the node int.c. So you come here and do vi, you paste the file name and you hit enter. So like I said earlier, we are trying to write a function that returns the end node of a dealing list. So here the code comment, we are including list.h. So back to the function proper. So the function, what we have, this is the function name. Okay, this is the function name, and we have arguments passed to this function. And the first one is the head. This is a pointer to the head of the doubly linked list. It's a pointer, and then we have another parameter or argument, which is index, which is an unsigned integer, which represent the index of the node to retrieve index here. So we have we declared a variable which is I, an unsigned integer. Okay, then we go ahead to use this conditional statement. As long as head is null, then we are going to return null. That means that the linked list the head, the beginning of the list doesn't exist. So if it is null, then we are going to return null. Then the program is going to end. So if not, then we'll continue running the program. Well, we have a while loop here. So actually, then the first while loop here is we have y head, arrow to previous is not null. It's going to move the head. It's going to move the head to the beginning of the list by following the previous pointer, like we explained. Okay, we have an arrow next and one previous. So what that does is that you're going to move the head to the previous. It's going to transverse through the loop. Okay, moving the head to the previous. You get here, move it to the previous again, move it to the previous till it encounters the null. It encounters the null, which is the beginning of the list. So that is what is happening here. So then it's going to move head continuously till we get to that. So again, here we are going to initialize the value, this variable, this I variable to 0. So we initialize that, and we have a second loop here which iterates. This loop is going to iterate through the list until it either reaches the desired index, which we are talking about, or the end of the list. That is the index we want to return or retrieve. It either reaches it or it reaches the end of the loop. Then we have the conditional statement. If we check whether I is equal to the index, the variable I, if it is equals to the index, then if we have a break. If it is, the loop will break and head will point to the node. It breaks and head is going to point to the node at the specified index. Then if it is not equal to, then what happens? Then it's going to advance head to the next here. It's going to advance, move head further, advance head to the next node, and then increment the value of I. Then finally, the code will return the node pointed to by head. Okay, the code will return the node pointed to by head. So at any index, if at any point, if the desired index is out of range, then it's going to return null. So that is the program. It's going to return null. So basically, we are trying to return the end node of a list, retrieving the node at any point in the linked list. So at the end, you can do your escape, $WQ to save and quit. So let's quickly look at the next one. Okay, which is this write a function that returns the sum of all the data of a linked list. So we want to return the sum of all the data. We have a prototype which we have included in the header file. So the next thing, we'll go ahead and pick the function name, the file name, sorry. And just going to do vi, and I'll paste that. Okay, so again, this is what we have. We are trying to return the sum of a linked list, the sum of all of the data. So this is the name of our function, and we have this argument passed to the function. And what this does is that this is a pointer to this structure variable, to pointer head to this structure, to D-link list structure, and the function is going to return an integer at the end of the day. It's going to return an integer. Then we declare the variable called an integer variable called sum, initialize its value to 0, and we use the conditional if statement. As long as head is not null, then we have the while loop. So first, you should know that this sum will be used to store the sum of the data element. The sum we are calculating, we are going to store it in the variable sum. Then the while loop here is going to ensure that the head points to the first node. Okay, it's going to ensure that the head points to the first node. All right, because it's going to iterate and transverse through the list, ensuring that the head points to the first node. If at any point it's going to move backward, previous until the head points to the first node. And while head is not null, then as long as head is not null, then sum plus head point to n. So what we are doing here, what we are trying to do here is that the loop will iterate through the list, adding the value of n feed of each node to the sum variable. So the value of n feed of each node will be added to the sum variable. Okay, to be added to loop through, and at any point it runs that, it's going to add the value of n to sum. Okay, then it moves to the next node using the next pointer. It gets to a, then after that it's going to move to the next node until it reaches the head, the end of the list. It transverses, forward. So like what we have here, this is going to loop backward, and when we are now calculating the sum, it's going to transverse from the beginning, which is the end, head of the list, transverse to the throughout the list till is going to get to the end of the list, because we have this as long as it is not null. So till get to null is it will not stop. Then at the end of the day, we are going to return the calculated sum of the data elements in the list. So the sum of the data calculated will be returned in the variable sum. So that is what we have. So once you are done, you can do your escape, shift colon WQ to save and quit. And okay, I will just quickly look through because the video is becoming quite long. So here we are writing a function that insert a new node at any given point, and this is the prototype here. So one thing you should note is that this code will reference to node underscore d and 3 node the previous files that were created. Okay, they said will be compiled during the correction. So if you go down here, though you just this, you see this, so that means whatever is you have here, whatever you want to get here will be dependent on these two add. You know, we created files where we needed to add a node at the beginning of the list, as well as adding a node at the end of the list. So several insert is going to reference that. So so what you do is that you are going to, and the implication is that if this is wrong, if this file you created here is wrong, then you know that this one will be wrong too. So you copy the file, several insert, and you come here, you do vi, and you're going to paste that. So I hit enter. Yes, this is the code we have, guys. So what we are trying to do, it's quite lengthy. I may not be going to too much details. Just know that we declared all of these variables. This is a double pointer to this structure. Is a double pointer. Then we declared an unsigned integer idx, as well as an integer n. Then we have these are variable declarations. Okay, these are parameters passed to a function, and the name of the function is this. So it's going to return at the end of the day, the return value will be a pointer to the linked list. Then we have all of that. So if we look through it, I'm going to drop the source code in the link that will help you. So this is the code, guys. So that you can do your escape, shift colon WQ. So you save and quit. So again, we have this, write a function that deletes the node that index of the linked list. So yeah, time is not fast spent, so just going to show you that, and then what I really want to let you know, how I have a separate video on the crack me. Okay, everything will be in the description of this video. So I'll copy this, and if I come here, I will do vi and paste. So we are trying to delete the node at index of the linked list in the linked list. So yeah, so we're trying to delete a node at a particular index. So this is a function name, and this is the function name, and you have two arguments, a pointer to the linked list structure. Then you have unassigned unassigned integer called index. So we have this variables declared and initialized h to head, and we have the if statement, which is going to check, going to check as long as hy is not null, then going to transverse through the loop from the previous move as transverse, to the previous node, so long as hy is not null. If it gets to null, then it's going to stop that loop, and here we initialize I to 1. This is the value where the node that will be deleted, where it will be stored. So you have a while loop, which we ensures that the node is not empty by checking if S1 is not null. If it is not, that means the head there's no head, the node is empty, is there no node, then it's going to use, we are going to use the if conditional statement to check if I is exactly same as index. Okay, so if it is, then we go ahead to again check if I is 0. Then if head is not exactly null, then it's going to transverse through the loop, moving to the previous loop from one node to the previous till it get to the null. Okay, then you have an else statement. So this is it, guys. Just go through the code and try it out yourself. The source code will be in the description of this video, so try it out yourself. Once you are done, escape column WQ. So that is it. And here, like I said earlier, for the last files, crackmin 4 and 5, I'm going to have a separate video on that. So this is becoming too long, so I'll add it here. So after you do all of that, you can do your git add dot git commit -m, then you do that, then you can push that to the remote. All right, after you have done that, I hope this helps. At least you have be able to pick some concept that will help you in this journey. I'll see you in the next video.